Hello, everyone. Welcome to a glance at the Java Performance Toolbox. Happy to be here with you in person, finally, at Vox Days Bucharest. I know we waited this event last year as well to be in person, but this year finally happens. I'm Anna. Thanks. A little bit nervous, although I know many of you, since you're my community. I'm happy to be here in front of you. I'm currently working as a developer advocate for Oracle in the Java Platform Group. And I'm also passionate about solving complex scenarios involving Java frameworks, Java, of course, and Kubernetes. I still love Kubernetes. I'm still working with Kubernetes. You can find me on Twitter at Umbra1508, but also on Mastodon, same handler like Umbra1508.mastodon.social. And let's talk. We have a lot to cover today, but if you have questions for me, I'm welcoming them after my talk as well, not necessarily during the talk, because there's another talk after mine, and I'm sure that we'll be having a lot to talk about. So you'll find me on the hallways, so just shoot me a question, welcoming all of those. So nowadays, everybody's kind of developing on the cloud, so the cloud is the hot thing that all of us wants to work with. So we're running our applications on clouds, and we have a lot of tools to work with, of course. And sometimes when we have so many tools available, many of them being open sourced, we tend to forget about those tools that are being shipped with the platform that we're working for so long, like the JDK, and we're not remembering them that well. So this talk is going to be a refresher on that, but also it's going to connect to the new world of clouds as well. Myself as a developer I have questions about using Java applications in containers, and probably many of you do recognize yourselves within my questions. Like, first of all, we all know that we have to make small container images. Everybody knows this, because small container images, they usually consume less resources, and pretty much we're chasing that all the time. And less resources, less space in the repositories as well. So which tools are there to help us to create container images, especially for Java applications, but with only what is needed at runtime, and help us, of course, maintain our applications on long term as well? How do we run those JDK tools, the tools that come with the JDK, in containers or proxy their output? Because nowadays, our applications are remote, so not everything runs on our local or becomes very accessible from our local to the clouds. Why and how can we capture the performance or anything that's relevant about our JVM and other application events? Fourth, which tools can help us fine-tune the JVM flags and keep the application overhead at minimum? And fifth, how do we correlate all this data from JVM monitoring tools to other tools that we're more familiar in the cloud world, like Prometheus or Grafana? So let's try to answer all these questions in the talk of today. Pretty much the tools, nowadays we have a lot of tools available to build OCI-compliant images. And these are just the tools that I've worked with, but I'm sure there are many more available. And probably many of you have started with Docker, then varied to build packs, Jib, Canico, build.s2i, and of course, a lot more available. All of them open source, of course. So the good old Docker file is pretty much how we all started. Can you please raise your hands if you ever touched a Docker file? OK, good. So this should be a little bit familiar for you. Like, there's a from, you copy some resources, you run some commands, and then you have an entry point. And usually you start like this. You have to have a small base image. Everybody knows this because you want to have the small container image, so the base has to be small as well. Now, besides this, you want to reuse that image to have images with common layers. And fourthly, you want to install strictly what is needed, so only what your application needs. Pretty much in case of a Java application is a jar file. And because I'm using shell script as an entry point for my application, an entry point.ch, nothing else. No need to copy a lot of other stuff, in my case at least. And yes, I have a question for you. Actually, first, how many of you are Java developers or familiar with Java? Can you please raise your hands? Good. So the question is, Can somebody tell me what happened with the GRE starting JDK 11? Yes?
It made Java aware of the container limits, or was it earlier?
You know something, but not that. You know something, but not that. There was an issue with JDK 8 about the container limits, but it was fixed with a patch later. But no, we can discuss that afterwards. So what happened with the GRE after JDK 10? Sorry. Modules, yeah, they were from 9, yeah. More? There's no. No.
They make it not happen. Made it bigger?
No, somebody said something here in the front.
I see that a lot happened.
Well, a lot happened. So the GRE is not present in the JDK anymore. That's the thing. So it's not shipped anymore with the JDK. So pretty much when you're trying to do this from, you kind of have to find a GRE. And the funny story is that I told this missing GRE to a very good friend of mine that works with Java 8. And he was very shocked and asked me how I'm going to develop Java applications now. So for him and others that are worried about how they make their own GRE, there is a solution to create your custom Java runtime for your container image. And it's called JLink. So JLink is available as a tool in the JDK, starting with JDK 9. It's a command line tool to link modules. And these modules can be in an image file, or you can generate runtime images. And these runtime images are using only the modules that your application needs. Cool. So let's see how JLink is actually looking like. So JLink packages in a legacy JDK image used to have the GRE, right? Now, starting with JDK 9, you could use JLink. But since JDK 11, there's no GRE, people started to look more into JLink, into making their own modular runtime image. So you can make your own image based on the modules that your application is using. So now you can maintain your good old Docker file with your own custom runtime build. So how am I going to maintain my Docker file, my old Docker file that I showed you earlier? I'm going to, of course, have a runtime stage build where I'm going to build my GRE from a JDK-based image, created with JLink, and of course, then the application stage build. All this to have that small container image that we all wanted, right? We know that our container is performant as long as the container image is small. So the runtime stage build now looks something like this. And you can see that the from is OpenJDK 20, since JDK 20 is released for like 2 days now. So I'll have to use the latest and the greatest. And of course, I'm running JLink to add specific modules that my application needs to run in a container. It's a Spring Boot app, by the way. And some of you are going to ask themselves, like, which modules do I add? How do I know which modules to add? That's an easy question to answer to with another tool called JDEPS. So just by simply running JDEPS with a command similar to mine there, which I didn't modify to 20, yes, that's a typo there. So JDEPS and minus multi-release, in this case, should be 20, not 19, but I forgot to change that one. Get you the exact list of modules that your application is using. So you're creating your own custom GRE with the minimum needed. You don't build a GRE with everything because you might not use everything from there. Then, of course, you can strip the debug information from the output image. You don't need that necessarily. Then you don't need to know man pages, no header files. And of course, it's great to compress the resulted GRE. You have 3 options: no compression, a constant string sharing, and zip. In my case, it's zip for 2. And the last is, of course, output in a folder called Java Runtime. Besides this, now we can go with the application stage build. It's pretty easy. I'm just copying my GRE. So I'm just doing now from an operating system, because I need an operating system to run to. And of course, I need the GRE. Now, since I'm not using the from GRE, I need to copy it from the previous stage and just make that one the Java home. Then I can continue with my application deployment and copy all the other artifacts. And if I need to override some environment variables for my JVM, I can use the JDK Java options for that. So, and of course, last but not least, run the application. Easy as that to create your own small container image with your own GRE. But this is great. However, oftentimes we encounter problems with our applications. And then we start looking how our JVM is running and how it started. And think about fine-tuning the JVM flags. Most of the time, these JVM flags help us to identify memory leaks as well, or to get more from the diagnostics commands that we can send with a specific tool called jcmd. So you can track the native memory that your application is using with jcmd. What the native memory is the memory that your JVM is getting allocated from the OS. And includes the heap memory. So you can look at that one when you're having memory leaks and can give you some ideas about that. A jcmd is the tool that can help you to send diagnostic commands to your running Java application. How do you work with jcmd in a container? First of all, you need to add it as a module, jdk.jcmd, like it's there. And then you can just send commands with it, as I'm going to do shortly. So one thing to say is that jcmd is a tool that can send diagnostic commands, but if you're overusing it, like having scripts that poll all the time with diagnostic commands, your running application, it will cause overhead to it. So it can affect the performance of that VM. You just simply add, for native memory tracking, you need to add a flag, -XX native memory tracking. And that's when the JDK Java options comes in place. Is very helpful, because you can override that from Kubernetes, for example, at the environment variable without modifying anything else regarding your definition for your deployment. You just can do a kubectl set env, and that's it. And another thing, native memory tracking enabled all the time also adds to some application overhead as well. So only enable this with kubectl set env when you need to profile your application and you were triggered that something is wrong with your application. OK. You can create a diff using the jcmd command by using the jcmd and the ID of your virtual machine. First, create a baseline, vm.nativememory baseline. And you just can, Kubernetes, you can need to do the kubectl exec. And you can create a summary diff, again, with kubectl exec, do the pod name, and exec that simple command. But those being said, let's look a little bit at my application. And now praying to the demo gods. OK, so I have a Spring Boot application called to-do application. Probably many of you are familiar with the to-dos. You just insert a to-do item in a nice UI. Hopefully, you like it. And let's start it. So I have a Docker Compose with it, with my Spring Boot service. Whenever I'm changing something to my application, I can build it again via Docker Compose. And we're going to add some JDK Java options on the way to the running application. Also, because I want to observe my application, I have Prometheus to get some metrics from it. And because I would like to see more graphics, I'm using Grafana as well, and Prometheus as a source for it. So let's start the application first and see how the native memory tracking is with it. So Docker Compose app --build, and hoping that the internet is going to be fast. OK. Cool. So the application is up and running. In the background, let's see if I need to start the load now. No, I will not load the application. So first of all, let's look if the native memory tracking is enabled. Created a small script for myself to help me for today with dealing with my application. And similar to kubectl exec, I'm going to use the Docker exec for sending a command to my machine. So make this bigger, clear. flag.ch. Huh? Okay, so the jcmd and the ID of my virtual machine, vm.flags, shows the flags that I have enabled for my JVM. But if I'm looking into all these, the native memory tracking, all these are in alphabetical order displayed. It should be somewhere after min heap size and before the non-method code heap size is not there. But I also want to run jcmd to see how the memory tracking is. And in that case, I'm just going to do the vm.native memory. I'm going to say yes. And jcmd is really good to tell me that native memory tracking is not enabled. However, I don't know by heart all the flags. And another tool called jinfo, also shipped with the JDK, is there to help me and find out what I should set for my application. So the -XX native memory tracking flag. Yep. I'm trying to make it bigger after this one. Yeah. Okay. So let's go in here, make this a little bigger, and say environment, JDK Java options. Of course, not off. I'm going to say summary. Let me stop my Docker compose and run it again. Clear. Docker compose up -- build. So after doing this, let me clear this. If I'm going to go and run again the flag.ch, now my flag appears in the listed flags. So it's here, native memory tracking to summary. And I want for jcmd to show me the native memory that's currently being used. And, well, of course, going to ask me about jinfo and the last value that I gave it to the native memory tracking. What I used earlier for jcmd, the output of it, you can output it, of course, in a folder, or you can stream it in a different location, not just have it like this. This kind of output is useful when you want to see what's going on at a certain moment in time with your application. It gives you just an information at that point. But if you want to make a diff, as I said earlier, it's good to make first a baseline and then run the native memory diff on it. So for that, I have my track script, which runs the jcmd vm.native memory baseline, run a diff, and of course, it's going to output that as summary diff in my recordings folder, because I would like to see it here, and it looks nicer than that. Okay. So what would be that useful for? When trying to look over memory leaks with your Java application, you're going to look at the Java heap, at the number of threads that are being created, how the allocation of those is going on. And if there is an increase over time, that's going to be reflected in here, and you will be able to spot that. Moving along, besides all these, you can also enable monitoring to remote access from a remote host within your Java application. So if you're running your application in a container, you can use JMX to connect remotely to it. And of course, you need to do that in a secure way. So this is why you have the key store password. In my case, it's password123, but it's just as an example. You have a key store there, server.ks. And of course, how you can authenticate to that, and many more. Very important are the RMI port, which is 1099 and 1099 RMI and JMX remote port, because that port is going to be used for your application to connect remotely, by the tool that you have on your machine to connect remotely to that one. And of course, you're going to be asked for a password, likely, since you are having a secured connection to this one. So how does that work? I think, let me see if I have, no, I don't have it. jconsole. Yes. And I have my remote process as well, but it's running on my local host. I just need to proxy it. Thanks. Told you I'm nervous. Yes, it's an insecure connection. So I'm now connected to my local host, and I can see what's going on with my application. But besides this, I want to look over the memory consumption of it. So I want to see if something's wrong with my application, and I can take a heap dump for that. But in order to simulate a more impactful problem for my application, I'll do a small memory leak in a moment. So, yeah. So my application has a memory leak, but I need like 20,000 to-do items to get to the out-of-memory situation. So this is why I have the load.ch script that takes a while to be ran in order to create that problem for my application. And because I want to make sure that my application is going to crash in the right time, I'm just going to go with simulate, which is an endpoint to make even more problems for me. OK, let's get it here, now that we're in the problematic area. So I can run a command to see the heap dump and what's going on with my application, also from jconsole, from the hotspot diagnostics operations dump heap. So what I need to do is just give a place for my dump heap location. So it's going to be the recordings folder. It's going to be dump.hprof and true, and just enter. It takes a while. Come on. You're not connected anymore? One sec. Recordings. It used to. Because it's remote and takes a little while, I was expecting for this message, method successfully invoked, from the application. OK, let's stop the joy here, because I don't want to kill my application 100% now. So I have a heap dump of my application. And we can look with it, even with the profiler in IntelliJ and what's going on with it. If you're going to look at the what's going on with our application, you can see the classes and the allocation of that, and how many objects like that have been created. OK, just waiting a little bit for the biggest objects to be opened. OK, good. So now you can see what objects are consuming the most of my memory in here. And in case of my application, there is a small issue with a map. So my application, whenever I'm running and adding a to-do, I add tags to my to-do. And I'm using that to-do as a key in a hash map. However, I'm modifying that to-do via my scripts, but never modify the tags. So what happens is that my hash map keeps increasing, and because the to-do items get modified and they're a key in a hash map, their hash code is going to modify over time. And if you're going to try to remove, for example, that object from the hash map, that will not always, the initial object that you introduced will not be found anymore since you modified it. And this is increasing and increasing and taking more space, more heap space. And that's where the out-of-memory is going to get eventually in my application. And because I said that how do you flag and see the issue with that, you can look at the amount of objects that keep increasing, the biggest ones. And in this case, the hash map will keep increasing and be the biggest until we'll take all the spaces that is available over there. OK, cancel. How about getting statistics about the running Java processes? So you can also get statistics using JDK tools, like jstat and jmap. Jstat, as the name it says, gives you statistics. And in this case, jstat minus jutil gets you statistics about the garbage collection. And what it does, it runs 10 samples every 250 seconds to see how the garbage collection works. To print heap summaries, you can use jmap and use jmap minus histo and the LLM VMID. In this case, you're going to see a nice histogram of your objects and how they're allocated in the heap. Let's look over how we can do the same for our application that didn't die, hopefully. So let's go to query, query.ch. Actually, I think it died. And I thought that I stopped it in time. OK, so let me start it again. Clear. Start it. OK. Query.ch. So the jstat is running now, and it's going to output. Unlike my command, this one is going to sample 250 samples every 25 milliseconds. And of course, I also want to print the heap summaries. By the way, the one means LLM VMID, which is always the ID of my virtual machine in the container. So let's look at the stats first. So the jstats, make this bigger a little bit. So these are the jstats that I got from regarding the garbage collection and how that is working. There are like 250, and the minus h10 from here, it says like repeat the header every 10 lines so that you will not be lost in the amount of values that you see here and you forget what's the header of this output. What you should look for. So you should look for the promotion of objects when garbage collector is being run from Eden space, which is called here E, to old space O. And typically, that's a 0 on the E column, which I'm going to search for now. Hopefully, I caught a garbage collection. Otherwise, I need to run it again. OK, run it again. Query.ch. OK. Please. Yes. OK. And usually I think that, OK, let me run this to force the garbage collection somehow. It's sometimes very difficult to sample exactly at the right time to show it for the demos. OK, jstat. Good. Yes. Good. So I see now that some events were happening. So you can see that there was a switch first, and there was a garbage collection happening when the Eden space promotion happened here. And from 1957, the space from here was promoted to old space, and this one increased with 0.7. So you can see that the Eden space now is close to 0. All this promotion took 4 milliseconds. This is the time for that. And this promotion caused for the S1 to increase in size to 85.38. Now, the garbage collection, I'm using G1GC. In time, the space will be again compressed, and you will see that percentage from this shrinking time to time as garbage collector is running more and more over my data. What do you have to look into if you're having issues with your system? Most of the time, look into the promotion of objects and how much time it takes to them, and of course the percentage that they're using on the S1 column. So if you see an increase on S1 column, like a huge increase on the S1, but also a lot of time on the last column, that shows to you that you are having problems and your garbage collection is not running as expected. There is a lot of time taking over there over collecting your objects. How do you capture performance for your application? So to capture performance, relevant JVM and application events, you can use a tool called JDK Flight Recorder. So JDK Flight Recorder can help you get information about the events that are happening in your application. You can use it for profiling, but you can also get like long-term information about how your JVM is behaving, meaning metrics, that you can correlate later in Prometheus and Grafana. And that's what I'm going to do in a moment. So similarly to jcmd, you need to add it as a module, jdk.gfr. To enable it, you just have to use the -xx start flight recording. If you want to have profiling, you can use a profile settings, and you can also start, stop, dump a recording just to get information on that specific time from your JVM. So this is for profiling. You can have a fixed recording with default settings, so you can have a recording for only 10 minutes in this case, starting after 10 seconds, using the default profile. Or you can start a continuous recording and don't specify any of the durations, and of course use your own settings profile to that. And you can of course export your recording to your desired location as well. Where to use GFR streaming? So where to use the API, the GFR streaming API, to get information? Unlike profiling, this is useful to stream selected metrics about the JVM to your monitoring service. So you can send an average or a min or a max or anything from the JVM to your desired monitoring system. You can expose GFR data through other management APIs. You can have like remote recording connections and use this kind of syntax like ES, event stream, .on event, and capture the event name and its desired values on that. So pretty much that, it gives you the registration of that, about the GFR events. Let's do this for my application as well, for one of the events that I have. So for Spring Boot, I would like to capture all my application events when my application is ready to serve requests, of course. So in order to do that, I have an application listener that is triggered at application ready event. And of course, I need to capture these metrics and maybe send them to Prometheus in my case. I'm using the global registry to send these events. And as explained earlier, I can do a es.onEvent. Now I need an event name, and I can like just have it from upstairs because I have like 3 events, the JDK GC heap summary. Okay, maybe give it some details. Heap used, because I want to know the heap that was used. Now the recorded event, and on the recorded event, no, I don't need much from this one. I need event. Just need to remember how was my syntax on this one. Yes, on event. Forgot. So pretty much to build these ones, I'm using the gosh to build it, and I'm recording the event and then the ratio. Sorry, I can do this. Gosh dot builder. That was it. JDK. Sorry. I have it saved in my sorry about this. I just forgot the syntax out of nervousness. So for my latest event, I'm just ES on event, the JDK GC heap summary. And on the recorded event, I am creating the gosh to export it to Prometheus. I just forgot on which one it needs to be triggered first. So when the event is, before the event is about to start, build the gosh using the information from that event. And in my case, I just need the heap used, which is a long in the GFR API. And it's also great to have a description of my application, and of course, I'm registering it to my metrics registry. Before doing all that and export and see that also in the Prometheus side, I need to add a few flags to my Docker Compose. because I needed the -XX start flight recording. Okay. Docker compose up -- build. Okay. Send some load so that we can have some data as well. Good. Now, first of all, my application, I need to search for my metrics, and I'm going to do that in Actuator Prometheus. And the heap used, I'm just going to go by the name of it. So I already have like JDK CPM load for the JVM user, and in case also JDK garbage collection sum of pauses. And these all that are prefixed by JDK are from the GFR. And I just need to do heap, GC heap. So this is my event, the JDK GC heap summary. It uses my description, the bytes allocated by objects in the heap. And of course, it summarizes the events in a gauge that later on get collected in Prometheus. And if I'm going to execute this, I'm going to see the heap summary used for the last minute. You can see that started at 10:05 something. And even more, I can go in Grafana and look at how metrics are collected from the GFR all together with other metrics about my application, like HTTP server request seconds. So this is a simple Grafana dashboard. You're going to find it in my code. And you can see all the requests that happen for my application. Not that many gets, so there was not a lot of get done to my service, but I'm creating a lot of information, and I'm putting a lot of information as well. And you can see the heap summary, the one that I'm exporting via my gauge here, in comparison to the amount of requests that I'm doing for my application. The other event that I'm using, the JDK CPO load for the JVM user, is on the other Grafana dashboard versus the HTTP request. So the same HTTP request there. And you can see the load on CPU across each of the requests done there. So that's when to use the GFR streaming, so when to use the API. When not to use the GFR streaming. Now, GFR as a tool is used for profiling, the API for getting metrics, the tool for profiling. So if you need to consume the data at this moment, you start the recording, you stop the recording, you dump the recording to recording.gfr, and of course, you look at that recording with JMC, Java Mission Control, JDK Mission Control. Using the dump for analyzing data on the long term is not the purpose of that. That's why the streaming is there in place. You can create your own custom events by extending the JDK GFR setting control. So you can do it like this. You can make your own custom event and have its own processing. Then you can create your custom event by extending the JDK GFR event. Put some labels on it. The reason for the name, the labels, category, and everything is because when you're going to look at the dump, for example, you're going to look at the recording in the JMC, you would like to isolate the events that you created from the other events that are in the JVM. And of course, you can register it via the custom settings in your custom event via jdk.gfr settings definition. For my Spring Boot application, I have captured my GFR events in a dedicated filter. So it's called Flight Recorder Filter. And I am registering it with admin annotation. And for listening the custom GFR events and record their duration, I have used a servlet context listener for that. It's called Custom Metrics Listener. So this was it. This is the example. I'm welcoming your questions probably now a bit and then on the hallway so that the next speaker has enough time to prepare. This is where you find the code and all the other details that were in the session. Thank you. And I'll share the slides because they have some useful links at the end about how to use GFR, how do you find the APIs, how do you find the tools, and other useful things, because not all the time Google can help you find these with the latest JDK released.